Hi guys, welcome to Vedant Education. Today I have a problem from GATE 2011. So here is the question. Consider a closed surface S surrounding a volume V. If R is the position vector of a point inside S with n the unit normal on S, the value of the integral closed loop 5 R dot n cap ds is. So this question has to be solved, this integral has to be solved, and the value of this has to be found out. So the given question says that a closed surface S and surrounding a volume V. So there is a closed surface S surrounding a volume V. So let's just say there is a volume V around which there is a closed surface, and if R is the position of a vector of a point inside S. So if R, so if you say like R is a position of a point inside S with n as the unit normal on S. So n here is the unit normal on S. The value of the integral, so this integral here, so we have to find the value of that integral. So let's say 5 R n ds. So let's say that the surface, closed surface surrounding this volume V is a spherical surface, which is a sphere, and we have the value given here. So the value of this integral. So in this case, since it's a spherical surface, the value ds can be given as, so since it's a spherical surface, ds in spherical coordinates can be given as r d theta and r sin theta d phi, where theta is the elevation of this. So let's just draw this again. So if it's a sphere, then if this is the point vector r, so this is the elevation theta and this is phi, the azimuth direction, and the ds, which is a small surface here, the length is given by r d theta and the width of this surface is given as r sin theta d phi. So this is d phi and this is the width, and now we will just plug it in into this equation. So integration 0 to 2 pi, where phi is varying from 0 to 2 pi, and since it's a closed surface, and theta is varying from 0 to pi, and its phi can be taken out, r dot n, since they are in the same direction, we have r d theta r sin theta d phi. So this turns out to be phi 0 to 2 pi d phi and 0 to pi. This is just r, so r cube sin theta d theta. So it's 5 r cube into 2 pi 0 to pi sin theta d theta. So this turns out to be 10 pi r cube cos theta varying from 0 to pi. So 10 pi r cube, cos of 0 is cos of pi is minus 1, cos of pi is minus 1, and cos of 0 is 1. So this is 20 pi r cube. So the value turns out to be minus 20 pi r cube, We know that the volume of this sphere V is 4 by 3 pi r cube. Now we can write pi r cube equal to 3V by 4. So by substituting this into pi r cube, we get 20 3V by 4, which is 15V, and the answer is D. Thanks for watching. Check out other problems which I solve in the playlist here, and also check out the books which I recommend for preparing for the electromagnetic theory.